Hi everyone, today we're going to talk about how to identify asymptotes of rational functions. Remember that the rational parent function is y equals 1 over x. And when you graph it, the shape of the graph is a hyperbola, and this hyperbola has a horizontal asymptote and it has a vertical asymptote. So the vertical asymptote is right here along this vertical line x equals 0. We also have a horizontal asymptote right here along the horizontal line y equals 0. So we have a horizontal asymptote and a vertical asymptote. And we're going to talk about how to find those. In fact, we have plenty of experience finding the vertical asymptotes, but this is going to be relatively new to us today, and then this is complete. It's something called a slant asymptote. So sometimes your hyperbola does not have a horizontal asymptote. Sometimes it has an asymptote that's a line, some kind of diagonal line that's slanted, and the hyperbola looks like it's kind of squeezed in here, just like this. So it looks kind of like that. So occasionally you will find that instead of a horizontal asymptote, you have a slant asymptote. So we're going to talk about how to identify all of those different situations. We're going to start out with something that you should be familiar with, the vertical asymptote. So the vertical asymptote equation is going to be x equals something, some value, and to find the vertical asymptote of a rational function, you want to set the denominator equal to 0. Make sure that the denominator is factored, and you want to solve for x. We've done this in the past a lot. What you get is not part of the domain, so usually we set the denominator not equal to 0 so that we can figure out what is not in the domain. But in this case, whatever is not in the domain is the vertical asymptote, so we're setting it equal to 0. So I'm going to go down to number 1, and I'm going to look for the denominator, which is x plus 2. It does not need to be factored. I'm going to set it equal to 0. I'm going to solve by subtracting 2 from both sides, and x equals negative 2 is the value where we have our vertical asymptote. Now, if I were writing my domain, I would say that the domain of the hyperbola is all real numbers except x is not equal to negative 2 because there's a vertical asymptote here. So these two kind of need to match up. The only other thing that could be taken out of the domain is an x value where there is a hole. And since we didn't have any common factors on top and bottom to cancel out, there were no holes in number 1. So I'm going to move on to the horizontal asymptote. So this is new, and in order to talk about the horizontal asymptote, which will always be y equals something, we need to talk about the degree, because all of these mention the degree of the numerator and the denominator. And if you don't know what the degree is, you're not going to be able to determine where the horizontal asymptote is. So the degree is the highest power. And of course we're talking about exponents here, so if my polynomial is x cubed minus 4x plus 7, then 3 is my degree because the x cubed indicates that we have a degree of 3. That's the highest power in the polynomial. So if I look down at number 1, I have constants, I have x's, they don't have exponents, but we know that a 1 is implied here. So in both cases, the numerator has a degree of 1 and the denominator has a degree of 1. So we're talking about the highest powers in the numerator and the denominator. So we have 3 situations. This would be a good opportunity to make flashcards to kind of quiz yourself. For a horizontal asymptote, if the degree of the denominator is greater than the degree of the numerator, so that's a situation where we have x to a small power over x to a big power. So the degree of the denominator is greater. Then y equals 0 is the horizontal asymptote, kind of like the parent function. This is a degree of 1. This technically has x to the power of 0, so the denominator's degree is bigger, and it has y equals 0 as the horizontal asymptote. So that might help you make the connection. Now, if the degree of the numerator is greater, so we have x to a big power over x to a small power, the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote at all. This is a situation where you want to check for a slant asymptote. And then finally, we've gone over when the degree is bigger on top or bigger on bottom, but what happens when the degrees are equal? So we have x to the nth power over x to that same nth power. And when that happens, the horizontal asymptote is the ratio, or fraction, created from the highest power coefficient, so the numbers that are out in front of the x squareds and the x cubes and the x's and things like that. So the ratio of the highest power coefficients. So let's look at number 1 again. Trying to find the horizontal asymptote, I look at the degrees. This is a degree 1 and a degree 1. That doesn't fit these two situations, but it fits this one. So since the degrees are equal, that means the horizontal asymptote, HA, if you're unsure what HA stands for, the horizontal asymptote is the ratio of the highest power coefficient. So here are my highest powers. What's the coefficient of x? Well, that would be 1. What's the coefficient of x? Well, that would be 1. And 1 over 1 is just 1. So my horizontal asymptote is y equals 1. And finally, the slant asymptote. It only happens when the degree of the numerator is exactly 1 more than the degree of the denominator. So if that's the situation, if the degree of the numerator is exactly 1 more, that can only happen here. Because here, the degree of the numerator is smaller, and here the degree of the numerator is exactly the same as down here. So it can only happen when there is no horizontal asymptote. So in this case, since we have a horizontal asymptote, there is no slant asymptote. If there were, the way to find the slant asymptote is to use long division. So now that we've filled in all of the blanks, let's go to number 2. Number 2, I'd like to look at the degrees. So I have a degree 2 and a degree 2. That means that I have equal degrees. And just like in the previous problem, I take the ratio of the coefficients. So here, if I distributed this 2 into these parentheses, the coefficient of x squared would be 2. The coefficient of x squared down here is 1. 2 over 1 is 2. So my horizontal asymptote is y equals 2. Remember what we talked about. If there's a horizontal asymptote, then there cannot be a slant asymptote. The degree of the numerator is not one bigger than that on the bottom. It's the same. The last thing we need to do is find the vertical asymptote. So I'm going to go ahead and factor everything on top and bottom. 2, a difference of 2 squares, so x plus 3 and x minus 3. A difference of 2 squares again, x plus 2, x minus 2. I don't have any common factors to cancel out, so there's no holes in this hyperbola. But I'm going to go ahead and look at the denominator, x plus 2 and x minus 2. I don't want the denominator to be equal to 0. That gives me x values that can't be in the domain. But I want them to be 0 if I'm looking for the vertical asymptotes. So here, if x plus 2 is 0, x should equal negative 2 for the vertical asymptote. And here, if x minus 2 is equal to 0, then x should equal positive 2 for the vertical asymptote. So x equals negative 2 and x equals positive 2 for the vertical asymptotes. There are 2 in this problem. Let's go to number 3. Keep that page available so that you can kind of scroll up when you need to. Number 3. I'm going to look at the degrees. I have a degree 3 and a degree 2. The degree on top is bigger by exactly 1, so I'm going to look and see what that fits. It fits this one. That means there's no horizontal asymptote, so I'm going to put no, or none. But that means that I need to check for a slant asymptote, because the degree of the numerator is exactly 1 more than that of the denominator. It was an x cubed over an x squared. So I need to use long division to find the slant asymptote. It's going to be y equals something. Remember, it's just a line, like y equals mx plus b. So I'm going to set this up for long division, x cubed plus 0x squareds plus 0x's plus 1. And I'm going to divide this by x squared. Interesting. I could put x squared plus 0. That would be okay. So maybe I'll do that. Maybe I'll have x squared plus 0x plus 0. So maybe I'll start out with my x squared that was here, but then fill in all the 0 terms. So let's divide the first terms. X cubed divided by x squared is x. So I put that here. I'm going to multiply x by all of these terms. So x times x squared is x cubed. X times 0x is 0x squared. And x times 0 is 0x. Draw the line, change all signs. This cancels out. This is 0x squared plus 0x plus 1. Now I'm going to divide again. So 0x squared divided by x squared is 0. I'm going to multiply. 0 times x squared is 0x squared plus 0x plus 0. When I draw the line and change all signs, I have 0x plus 1. 1 must be my remainder. Now, the interesting thing about long division here is that the slant asymptote is an equation of a line. So this we don't really include. We kind of ignore that. And what you have here is what we write for the slant asymptote. You could put x plus 0, but it's unnecessary. So now, the only thing we have to find is the vertical asymptote. So I'm going to set my denominator equal to 0. I'm going to solve. I get x equals 0 from my vertical asymptote. There we go. So move on to number 4. I guess 4 and 5 can fit in the screen at the same time. So on number 4, I notice that I have the same degree. So my horizontal asymptote is made up of the coefficients of those x terms, so 1 over 1. So y equals 1 is my horizontal asymptote. Therefore, there is no slant asymptote. The vertical asymptote I get by setting x minus 1 equal to 0. So x equals positive 1 for the vertical asymptote. Okay, let's go on to number 5. Number 5, I notice that the bottom can be factored. So this is x minus 4 and x plus 4 over x minus 4. I notice that the x minus 4's can cancel out. So the resulting function is 1 over x plus 4. But this means that there is a hole where x minus 4 equals 0. So x equals 4. That's where the hole is. If I take 4 and I plug it in here, 4 plus 4 is 8. So the hole is at 4, 1/8. Now it's not something that we were asked for here, however, it is nice to be able to make the connections from previous lessons. So, for the vertical asymptote, if x plus 4 is equal to 0, x has to equal negative 4. That's the vertical asymptote. X does not equal positive 4 for the vertical asymptote. That's a hole. And together, we would write the domain as all real numbers except x is not equal to positive 4 or negative 4. Because at positive 4 there's a hole and at negative 4 there's a vertical asymptote. So if you're wondering why we use 1 for the hole and 1 for the vertical asymptote, they're both taken out of the domain, but the ones that have the common factors, that's where the hole is. What's left over, that's where the vertical asymptote is. Now the horizontal asymptote, I compare the degrees. This is degree 1 and degree 2. So I go back and look at my notes. When the degree on top is smaller, that fits this situation. So y equals 0 is my horizontal asymptote. And if there's a horizontal asymptote, that means there is no vertical asymptote. Let's go to the last page. Last page requires quite a bit of factoring, so let's go ahead and factor at the beginning of every problem. That way we can see if there's any holes that need to be taken out. So the difference of squares, x plus 2 and x minus 2. Two numbers that multiply to be 3 and add to be 4 are 3 and 1. So x plus 3 and x plus 1. There are no common factors, so there are no holes. The vertical asymptote is where you set the denominator equal to 0 and you solve. So if this is the factor set equal to 0, then x equals negative 3 is the vertical asymptote. If this is the factor set equal to 0, then x equals negative 1 is the vertical asymptote. So there are two vertical asymptotes in this problem as well. For the horizontal asymptote, I look at the degrees. A 2 and a 2, they are equal degrees, so I want to write the ratio of the coefficients. That's a 1 over a 1. So y equals 1 over 1, or just 1. That's the horizontal asymptote. And if there's a horizontal asymptote, then there is no slant asymptote. Let's look at number 7, factoring. The denominator is easy. It's a difference of squares. So x plus 2, x minus 2. For magic numbers, I need two numbers that multiply to be negative 12 and add to be negative 1. So I'm thinking of 3 and 4, but the 4 would need to be negative. Again, no common factors to cancel out, so no holes. The vertical asymptote occurs where the denominator is equal to 0. So if I look at the opposites of the factors, x would have to equal negative 2, and x would have to equal positive 2. Looking at the horizontal asymptote, I look at the degrees. 2 and 2, they are the same. So the ratio of coefficients is 1 over 1. So y equals 1 is the horizontal asymptote, meaning there is no slant asymptote. And finally, number 8. The denominator is already factored, but the numerator is not. So I need two numbers that multiply to be negative 2 and add to be negative 1. 2 and 1 would multiply to make 2, but I would need the 2 to be negative. No common factors cancel out, so there are no holes in the hyperbola. The vertical asymptote comes when x minus 1 equals 0, so x would have to equal 1. I notice here that my degrees are 2 and 1, so let's go back and look at what that means. If the degree on top is bigger than the degree on the bottom, there's no horizontal asymptote. And if the degree on top is exactly 1 more than that on bottom, then there's a slant asymptote, and I have to do long division. So here we have no horizontal asymptote, but because 2 is 1 bigger than 1, I have a slant asymptote, y equals something, so I need to do long division. So x squared minus x minus 2 over x minus 1. X squared divided by x is x. X times x is x squared. X times negative 1 is negative 1x. Draw the line, change both signs. These cancel. These also cancel. There's 0 x's. Bring down my minus 2. Divide again. 0x divided by x is 0. So I'm going to put plus 0. 0 times x is 0x. 0 times negative 1 is plus 0. When I draw the line and change both signs, these cancel. This is negative 2. It's my remainder, but it doesn't matter. I don't write it. I'm just going to write the x part right here. I could write x plus 0, but it's not necessary. So in summary, the vertical asymptote comes from the factored denominator and setting it equal to 0. The horizontal asymptote could be many things, but you determine what the horizontal asymptote is by looking at the degrees of the coefficients, the degrees of the numerator and denominator. If the degrees are the same, you write the ratio of the coefficients for your horizontal asymptote. If the degrees are different, perhaps the degree is, let's see, there we go. This is a good example. Perhaps the degree is bigger on the bottom than on the top, then y equals 0 is the horizontal asymptote. And if the degree is bigger on top than on bottom, then you have no horizontal asymptote. And if it's only one bigger, then you have to do long division to get your slant asymptote. So that's a quick summary of these notes.